Okay, here's another video. So let's start with enthalpy, and you have to find like the enthalpy of the reaction, and you're going to be given a chart, and it's going to be like bonding energies. That's enthalpy, and so it can be determined by subtracting the sum of the enthalpies of the reactants and the products. So for this example, this is like the values found in the chart, except carbon and chlorine were not found, but they were given on another problem set, so I took that from there. And then you put it here, and since there's four, there's two, and 4. So that's kind of like how you do that. And then what else? Okay, so that's the math for this, and then it's gonna come out in kilojoules per mole, and that's how this is in the chart. And then you just add, multiply. Oh, you don't multiply. Well, multiply these, add these, subtract. That's just math. You're gonna get this. And then it's negative, which means it's like releasing, no, it's absorbing energy. Negative, it's absorbing energy. All right, now for this is just, it's a chart. I have a better, so this is here just to have on the notes page, but this is a better chart, and I have a, where is it? I have a whole video explaining that if you want to go watch that. And then, so the question of bond length came up. And so the higher number of bonded electrons, so 2 electrons, 1 bond, 4 electrons, 2 bonds. So the higher number of bonded electrons, or bond order, the stronger the pull will be. So the more electrons you have, the stronger the pull. But then if you're pulling like a rubber band and it's really tight, this space here, pretend a rubber band's on my fingers, and we have a loose rubber band and it's stretched really far out, that's long and there's not a lot of pull. But say I wrapped it around my finger 3 times, it's going to be shorter because it's pulling stronger. So then this is the longest and this is the shortest. 1, 2, 3. All right, now this is going to be determining molecules and whether they're polar or not. And I think the best way to explain this is that polar molecules will have an even distribution. Like these are pleasing to the eye. You have, everything is full, happy, bonds are satisfied, and so you kind of set up the Lewis dot structures for each molecule, and then if it looks even and it's well distributed and it's not like this is equally charged or evenly distributed, this is non-polar. But then this, on the other hand, so here's like, so this is equal, this is not. This is it's further out. So like if you have a similar atom, if you have the same atom, it's going to be non-polar. But if you have different atoms, and this one's all the way on this side and is more electronegative, or this one's more electronegative than this one, this is partially positive, this one's partially negative, so that means it's polar. This one has a partially negative up top and 2 partially polar, or partially negative and then 2 partially positive, so then this has a pole. And this has a pole as well because it's the same thing, just more. So if it's not evenly distributed, then it's polar. All right, so that was just a quick little rundown of the ending of chapter 7.